Please title these notes Applications 1 Notes, Position, Velocity, Acceleration, and write today's date. By the end of this lesson, you should be able to use the sign charts, the little lines, and this table here to solve problems with position, velocity, and acceleration. The basic scenario is that something's moving back and forth along a straight line. So, for example, the little moving man demonstration that we've worked with, where he's moving just back and forth basically along an x-axis. What we're doing is we're imagining that there's a moving man or a squirrel walking on a wire or a bug walking on a wire or just a particle moving along the x-axis that's moving back and forth. And what we're trying to figure out is what can we determine about its position, its velocity, and its acceleration. So the key thing to know about this is that these problems are the same as f prime, and f double prime problems. F corresponds to position, f prime to velocity, and f double prime to acceleration. So what that means is it means that if I start off with position with respect to time, incidentally, P of t, for whatever reason, is not very commonly used. This is also written as S of t, don't know why, or x of t. All those are position. The derivative of position is going to be velocity with respect to time, so that's velocity. The derivative of velocity is acceleration. And then going back up the other way, the antiderivative of acceleration is velocity. The antiderivative of velocity is position. So position, take the derivative, you get velocity, take the derivative, you get acceleration. Acceleration, take the antiderivative, you get velocity, antiderivative, you get position. Same idea as with f. Derivative is f prime, derivative of that is f double prime. To solve these problems, use sign charts, that's these, just like you did for f, f prime, and f double prime. First though, you need to know what the problem is asking for. Right here is a chart of all the different words that mean different things in terms of mathematics. So, for example, if we're talking about when a particle is traveling to the left, that means the velocity is negative, traveling to the right means the velocity is positive, and so on and so forth. This is incredibly, incredibly critically important to memorize. Absolutely, absolutely, absolutely must be understood and memorized. Sleep with it under your pillow, or you'll be eaten by a dragon. Make sure you have it down. Should also be aware, right at the end of this, for all real-world problems, time is always going to be greater than or equal to 0. We don't have such a thing as negative time.